So today's our topic is direct and inverse proportion in algebraic terms. We already seen what is a direct proportion, what is inverse proportion. Now we'll see the algebraic terms about that and we'll try to solve some problems based on that. We have discussed what is direct and what is inverse proportion briefly. Let's just revise that very quickly. The direct proportion comes when there are two things. For example, one is x, second is y. And let's say when the value of x is 1, y is 5, x is 2, y becomes 10, x becomes 3, y becomes 15, x becomes 4, y becomes 20. So if the value of x is becoming double, y will also become double. If x becomes triple, y will also become triple. If that kind of relationship is true between x and y for all the values, then we see that x and y are directly proportional to each other. And the mathematical test based on which we can predict if x and y are proportional, directly proportional or not, that test is x upon y must be equal to constant. So we can check the value of x and y, and for all these values we see first is 1 by 5, second is 2 by 10, third is 3 upon 15, and fourth is 4 upon 20. All of these values are coming as 1 by 5, 1 upon 5. So all these values are equal if the ratio between all values of x and corresponding values of y, if all those ratios are same, then we say they are in direct proportion. So this is a direct proportion. What can be the test for inverse proportion to? So if one value is x, second value is y, and let's say when x is equal to 24, y is 1, x is halved, y does not become half, it becomes double. X is divided by 3, so you get 8 here, y becomes 3 times 10. You get 6 here, 4, then 4, 6, then 3, 8, and so on. In these values, if you check, if this value x is becoming half, then y is becoming double. Or if x is becoming 1 by third, y is becoming triple, and so on. And the test to check if they are in inverse proportion is x into y must be constant. So we'll check 24 into 1, 12 into 2, 8 into 3, 6 into 4, 4 into 6, 3 into all of them are equal to 24. So if the product of the two terms is constant, that means these both terms are inversely proportional to each other. If their ratio is constant, they are in direct proportion. If their product is constant, they are in inverse proportion. That's the basic that we need. We'll solve some numericals based on that term. Let's see this example. Y is directly proportional to x cubed. Now let's just understand this. Y is not directly proportional to x. The problem says that y is directly proportional to x cubed. This line can be symbolically written as this alpha-like symbol is a symbol for direct proportion or proportion. So y is directly proportional to x cubed. If a and b are proportional, directly proportional, so we say a is directly proportional to b. If they are inversely proportional, we will say a is proportional to 1 upon b. This is inverse proportion, this is direct proportion. We can just solve further. Like in this problem, we just take the values. Y is directly proportional to x cubed. When x is equal to 2, y is equal to 32. We know that if the two things are in direct proportion, then their ratio is constant. So we will say y is directly proportional to x cubed. Therefore, y divided by x cubed is equal to constant k. Here please note this, I am not saying that y upon x is equal to constant, because y is not proportional to x. It is proportional to x cube. So y upon x cube is equal to constant k. Value of y is 32 upon x cube is 2 cube is equal to k. So 32 upon 8 is equal to k. So k is equal to 4. So you get this value. This is being solved here as well. So you get k is equal to 4. The value of k is equal to 4. So we can say that y upon x cube is equal to k, that is 4. So we will multiply and divide y is equal to 4x cube. This is the relationship between x and y that we established from the given values. Now find the value of y when x is equal to 5. So if x is equal to 5, y is equal to 4 into 5 cube. We'll put x is equal to 5 here. So if it was x cube, it will be 5 cube. 5 cube is 125. 4 into 125 is equal to 500. Y is equal to 500. And we got this value. The next one. F is inversely proportional to d square. This is there for all laws. Coulomb's law of electricity. Then there is Coulomb's law in magnetism. Then there is gravitational law. In all these laws you see that the force is inversely proportional to d square. It is written like this. Proportional 1 upon d square means inversely proportional. So if that is true, then the multiplication of these two quantities f into d square must be equal to constant k. So d is equal to 3, f is equal to 12. So f is equal to 12 into d is equal to 3 square is equal to k. So k is equal to 12 into 9. 12 into 9 is 108. So this is equal to value of k. K is equal to 108. Now we will see the next question is find the value of f when d is equal to 4. So f is equal to f into d square is equal to k. The value of k is 108. So f is equal to 108 upon d square, which is equal to 108. We want to find out the value of f when d is equal to 4 upon 4 square. This is 108 upon 60. This is equal to 6.75. You can check this value. So these are the similar examples. Let's see the exercise now. Y is equal to kx, where y is equal to 16, x is equal to y is equal to 24, x is equal to 16. Calculate. So y is equal to kx. That means y upon x is equal to k. So this is the case of direct proportion. Y and x are directly proportional to each other. Now we have given the initial values. So we find out k is equal to y upon x. What is the value of y? 24 upon x is 16. This is equal to 3 by 2, meaning it is 1.5. So we get the value of k. And after knowing the value of k, we will find out other values. So when this is a, finding the value of k. B is find the value of y when find the value of y when x is equal to 10. So y is equal to kx, k is equal to 1.5, so 1.5 into x. So this is 1.5 into x is equal to 10. So value of y is 15 in this case. So b is done. See x when y is equal to 12. So y is equal to kx. X is equal to y upon k divided. The value of y is 12 is equal to 12 upon 1.5. That will be equal to 8. So the value of x is equal to 8. You can check these values. Question number 2. Some corresponding values of p and q are given in the given table. Are P and Q inversely proportional? Justify your answer. If they are inversely proportional, then at every point, every value, the product must be same. So 2 into 75 is 150. 5 to 30 is also 150. Great. But 8 into 20 is not equal to 150. It is 160. And 12 into 15 is 180. So these two values are actually satisfying the required conditions. But these two are not. And for any two values, any two quantities to be in inverse proportion, their product must be same always, not like for one or two values. So this is not, the product is not constant always, so that is not inverse proportion. So we have to say this is not inverse proportion. Question number 3, for the following, y is inversely proportional to x. So if y is inversely proportional to x, that means y into x is equal to constant. Write an equation expressing y in terms of x if this value is given, this value, this value. We'll solve for a only, b, c, d, all you have to solve. So we'll take the value y is equal to 0.225 into x is 20 is equal to k. So the value of k is 4.5. And then from here I can say that y into x is equal to k, and k is 4.5. Y into x is equal to 4.5. And then we will ask to write an expression for x in terms of a. So we'll take x this side. So we'll expression of y in terms of x. So we have 4.5 divided by x. This is an expression of y in terms of x. What is answer? Similarly, let us solve for B, C, D, E. Question number 4. The question says that y is inversely proportional to x cube. Y is inversely proportional to x cube. That means y is proportional to 1 upon x cube. If y is at 80 when x is equal to 4, y into x cube will be equal to 8. When y is equal to 80 and x is equal to 4, this is 80 into this is 4 is equal to k. So k is equal to 80 into 4 cube is 64. 64 into 8. 5120 will be the multiplication. So you got this answer. Then we found a constant of proportionality. The constant of proportionality is what is k is 5120. Then the value of y when x is equal to 8. That's right. Y into x cube is equal to 5120. Now we put the value of x here 8. Y is equal to 5120 divided by 8 cube. 8 cube is 512. 512 common 512 is 10. So the value of y here is 10. Then we put the value of x is equal to 6. Here we can put the value of y is equal to 24. You will get the value of x. We'll solve d. We'll solve d though, because d is will require a little bit of more adjustment. So we have y into x cube is equal to 5120. And from here we can do this. If y into x cube is 5120, y is 24 in case. In this case, d says y is equal to 24. So 24 into x cube is equal to 5120. X cube is equal to 5120 upon 24, which is equal to, this is 640 upon 3. And not cannot be divided further. So we get x is equal to cube root of 640 upon 3. And that is good. Question number 5. Y is inversely proportional to x square. So y into x square must be constant. We will complete the table now. So we have y is inversely proportional to x square. So y into x square is equal to. So we have, what is the value of y? 1. We'll take those values where x and y both are known, so I can find the value of k. So I will write y is equal to 1 into x is equal to 0.5 square is equal to k. So 1 into 0.5 square is 0.25. So the value of k is 0.25, or we can write 1 by 4 as well. And from this value, we can find out the value of y is equal to 0.25 upon x square. Now for here, this is equal to 0.25 upon 0.1 square. This is equal to 0.25 upon 0.01, which is equal to 25. So this will come as 25. And accordingly you can fill in these values. We'll take this example last. This is, so if the, no, we'll solve this when the value of y 0.25 not here. So we have y into x square is equal to 0.25, and we're solving this. So when the y is 64, fine. So we have 64 into x square is equal to 0.25. X square is equal to 0.25 upon 64, and x is equal to square root of this 0.25 upon 64. If you know 0.25 is a square of 0.5, so the square root will be 0.5. Divided by 64 is the square root, so square root of 64 is 8. 0.5 upon 8 or 1 by 16. Both are correct answers. Y is proportional to square root of x. Complete the table. And the question number 7. I think these are easy questions. 7, 6 and 7 you can manage. If there is any difficulty, surely tell me. Question number 8 as well. We'll solve question number 9, 10, 11. Question number 9. A is proportional to r square. When r is equal to 3, a is 36. Find the value of a when r is equal to 10. So a is directly proportional to r square. Maybe a is the area of the circle and r is the radius of the circle. You only guessing. Maybe true, may not be true. So because the area of the circle is proportional to square of the radius. So a is proportional to r square. When r is 3, a is 36. We'll first write a upon r square is equal to constant, because that's how the direct proportionality works. Now we get this is equal to a is equal to 36 upon 3 square is equal to 36 upon 9. So k is equal to 4. Then in that case, find the value of a when r is equal to 10. So a upon r square is equal to k, but k is 4. So a is equal to 4r square. So a is equal to 4 and r is 10, 10 ka square. That is equal to 4 into 100 is 400 is the area. And we get this. Question number 10. L is inversely proportional to dq. L is inversely proportional to dq. When d is equal to L is equal to 100, I don't think we should be worrying about this. I will not solve this part further. L into dq is equal to constant proportionality k. Because it is inversely proportional, so multiplication product must be constant. So L into dq is equal to k. Now you have the value of d, you have the value of L, put them here, you will get the value of k. Using that value of k, at this new value of d, you will get the new value of L. Just calculate like that, you will get the answers. Same should be here. Electric current I flows through a resistance R. It is known that the I is inversely proportional to resistance. So current and resistance are inversely proportional. Effectively, current into resistance is equal to constant K. This constant K is called as voltage. This is Ohm's law. So current I and resistance are inversely proportional. That's why I into R is equal to constant K. When I is equal to 3, R is equal to 3, I is equal to 5. So I is 5, R is 3, is equal to K, so K is equal to 15. Find the value of I when R is equal to 0.25. So I into R is equal to 15. I into 0.25 is equal to 15. So I is equal to 15 upon 0.25, which is equal to 60. So the current will be 60 amperes in this case, if these values are there. Question number 12, you can still solve further. The tables are given. Which of the statements are true? T is proportional to S. Let's check if they are proportional. If they are proportional, their ratios must be constant. So 2 upon 0.4 and 6 upon 10.8, they are not proportional. This is surely not true. T is proportional to S square. Now we'll have to check this. See this, we'll have to check T and proportionality X square. So T, the value of T is 0.4, 10.8, 50. And S square, 2 square is 4, 6 square is 36, and 10 square is 100. Again, the ratio is not constant. If they are directly proportional, the ratio should have been constant. It is not constant. It's not working. Maybe let's try this T and S cube. T 0.4, 10.8, and 50. And cube is S cube is 2 cube is 8, 6 cube is 216, and 10 cube is 1000. Now they are perfectly proportional. You see that if you divide this by this, it is 1 upon 20. If you divide this by this, it will be 1 upon 20. And if you divide this by this, you get 1 upon 20. So in this case, the ratio is constant. So you get T upon S cube is equal to constant. Therefore, T is directly proportional to S cube. And we verified these values. First two ones are false, third one is true. Question number 13, 14, 15. Which one should we take? I think we take 13 and 14. 15 and is there anything 16 as well? I think no, 15 is the last one. Fine. So 13, 14 will solve. Oh, there is 16, 17. Yeah. So okay, let's take 13. It takes 4 people 10 hours to plaster a section of building. See, it is an open secret. If you employ more people, you have to, let's say, you have to plaster this wall. So if you are plastering this wall, if there is only one man, it will take longer time. If there are 2 men, it will take more, it will take lesser time. If there are 3 men, it will take even lesser time. So more men you put or more people you put to work, the faster the work should finish. I am not, and we are not considering that more people will sit together and just start chatting with each other. We are not talking about that situation. We are saying that the productivity will increase, so effectively required time will reduce. So the number of days or number of time and the number of people are inversely proportional in this case. So it takes 4 people 10 hours to plaster a section. So people and time in hours. 4 people, 10 hours. How long will it take 8 people to do the same? Because they are inversely proportional, their product must be constant. So 4 into 10 is 40. This 8 into something must be equal to 40. It should be 5 here. So you just have to assume this is X and then say product is constant and you get the answer. In an industrial experiment, it is found that the force F needed to break a concrete beam varies inversely with the length L of the beam. The logic is, if you take the length, this is the beam and this is the length of the beam. If this length increases, then the force required to break it, let's say there are supports at the end. If these supports are more and more and more and more apart, then with one back of your hand you can break this. But if these supports are very close to each other, you can use hammer or you can use any other device, but you cannot break this that easily. So what is said is the length and the force have a specific relationship. What is that relationship? If this is the length of the beam, then the force required to break this length or break this beam is inversely proportional to L square. See this. The force required to break a concrete beam varies inversely with the length L, not L square. It is varying inversely with the length L. So it means that F into L must be constant, and we'll call it as K. F into L is equal to K. If it takes 50,000 newtons to break a concrete beam 2 meter long, so this is the force 50,000, and this is the length 2 meter. So K is equal to 100,000. So the value of K is obtained. How many newtons will it take? So next is, if the length is 6 meter, so F into 6 meter must be equal to K, but the K is constant, 100,000. So F is equal to 100,000 upon 6, which is equal to 50,000 upon 3 is 17 point, 16 point. 16,666.66 recurring. This is the answer. 10,000, 100,000 upon 6. You can get the answer. You will see that the length initially was 2. Then the length becomes 6. So this has become 3 times multiplied by 3. And because they are inversely proportional, if this becomes 3 times, this will be divided by 3. So it is now 50,000 upon 3. Just check the logic, you get the answers. A submarine crew discovers that the water temperature varies inversely with the depth. You go more deep, then you realize that the more the depth, less the temperature actually varies inversely. So, varies inversely with the depth. More deep you go, lesser is the temperature. If you are more surface you are on, or you are near the surface, the temperatures are more. When they were at a depth of 4 km, the temperature was 6 degree. Write this. Temperature is, let's say, T, or T is used for time most of the time. So let's call it theta. Temperature multiplied by depth is D is equal to constant. Why? Because there is inverse proportion here. Theta is for temperature, D is for depth. Initially, the depth is 4 meter and the temperature is 6. So 6 into 4 is equal to K is equal to 24. 6, the depth is in kilometers and the temperature is in degrees Celsius. What will be the water temperature be at the depth of 12 km? So what will the temperature of the water be at a depth of 12 km? So we'll put this depth is equal to 12 km. Theta into depth is 12 km is equal to K is equal to 24. Divide here, theta is equal to 2 degrees Celsius. What depth do they need to reach for the water temperature to be minus 1 degree Celsius? We'll put this temperature is minus 1 into depth D is equal to 24. So the D has to be equal to 24 upon minus 1, that is minus 24. Minus 24 kilometer is not possible. The depth cannot be negative. The depth is already taken as positive. Why? Because you are measuring in this direction. So this distance is taken as positive. Minus 24 is above the water surface, but this entire logic is based on below the water surface. It means that it is impossible. That means no matter how deep you go, the temperature of water will not be minus 1 degree Celsius ever. That is the right answer. Question number 16, and we'll stop with this. Variable p varies directly with variable m and inversely with variable n. Okay, p is varying directly with variable m and it is varying inversely with variable n. So we'll combine this together. Mathematics allows us to combine this. So p is proportional to m upon n. So we say that when p is equal to 24, so we write p is equal to the constant into m upon n. Or you can say that, with the logic of what is proportional and directly proportional, inversely proportional. These two things are inversely proportional, their product is constant. These two are directly proportional, ratio is constant. So we'll put that together and we'll say p into n, because they were inversely proportional, the product. And this is in ratio, so divided by this because that is directly proportional, is equal to constant. ये और ये दोनों same है. You can check this. P is proportional to m by n, so P is equal to k n by n. And then n can be multiplied here, n will be coming as division, and you get this as well. So you can jump from here to here directly, or write this and get this. Both are absolutely same. When p is equal to 24, m is equal to 3, n is equal to initial value is given. So p is equal to 24, k into the value of m is 3 divided by the n is 2. Cross multiply, you will get k is equal to 4 into 24 into 48 upon 3 is equal to 16. So k is equal to 16. Find p when m is equal to 5 and n is equal to 8. P is equal to k m by n, which is equal to 16 into m is 5 and n is 8. This is equal to 10. Cross multiply, you will get answer. This is a mistake. A and B, these are not two different questions. You need to find out the value of P. You must be given both the values of m and n. Only one value will not suffice. You cannot say A independently and B independently. These both values are necessary. Only they can calculate the value of P. 17, you can take for homework. Should there be any doubt, any problem, you can always tell. So we come to the end of this chapter. It's been a long chapter, ratio, rate and proportion. We covered everything, including the graphs. I hope that this will help you. And I hope you saw this. I hope you are watching this video. And should there be any problem, always feel free to reach